Hello, my dear students of Benguet State University. Welcome to our online class. I am your teacher, Jan Lasea. Ladies and gentlemen, this is my lecture in our laboratory subject of Mobile Application Development 1. Today, I discuss the laboratory hands-on activity number 1 entitled Activity Life Cycle on page 8 of the laboratory manual. But first, let us review again this topic, event-driven programming, that you finished in the past semester. Event-driven programming is a style of programming used to process events. An event is a condition that arises during the lifetime of a program. An event handler is an active program unit which is invoked in response to the event. An event occurs in response to an action such as the user clicking the mouse or pressing a key in the application. An event handler is a routine that responds to the event. Some examples of event-driven programming like C#, Windows Graphical User Interface Programming, Visual Basic Windows GUI Programming, Game Programming, C++, Win32 API Programming, Java, Windows Graphical User Interface Programming, and of course our subject, Android Java Apps Programming. Next, let us learn the different events that a mobile app's activity must undergo. But first, let us understand the meaning of activity. Activity in Android software development represents the visual representation of an Android application. It is the building block of the user interface. To be straight into the point, an activity is like a page in a web app. The image down below shows the activity life cycle. The labels that has a brackets, opening close parenthesis, indicates the event handler, whereas the round shape rectangle represent the state or the status of that event. Next, let us learn when we run our mobile app in a smartphone by understanding how a mobile app's activity will be run by the Android operating system together with the Android device CPU. On the create handler or method, once that the onCreate handler or method finish the execution, the system calls the method or handler onStart. From the handler onCreate, the mobile app activity status became created, and then after that it will proceed. The CPU will jump to the method handler named onStart. The system calls the onStart handler or method and onResume handler or method in quick succession. Your activity never resides in the created or started states. Technically, the activity becomes visible to the user when onStart method or handler is called, but onResume handler or method quickly follows and the activity remains in the resume state or status until something occurs to change that, such as when a phone call is received, the user navigates to another activity, or the device screen turns off. So let us imagine if we run the time deposit mobile app. The first activity will be the created activity. The CPU will jump to the handler onCreate, and then the status of that time deposit will be created, and then next the CPU will jump to the method handler on start, and then the status now changed to started, and that's the time that the time deposit graphical user layout interface will be visible to the user. And then the CPU goes to the method onResume handler, and then the status now will be resumed. Let us run the laboratory hands-on activity number 1 entitled Activity Life Cycle using the Android emulator. The Activity Life Cycle mobile app displays information at the center that indicates the events that happen when we run this mobile app. At the start, the constructor main is not part of the activity life cycle. In object-oriented programming, a constructor is a special member function or method that is automatically invoked whenever an object of that type is created or allocated or instantiated. It is used to initialize the objects. After the constructor main is done, run by the smartphone CPU, the CPU goes now to the method handler on start, as we learned in the activity lifecycle image a while ago. And then after that, the CPU went to the method handler on resume, and then after that, it went to the method on post resume, and then the graphical layout appears visible in our Android emulator device. What will happen if we switch to another activity in our Android emulator? I will click this home screen so that I can run any mobile app. By clicking this home screen, our mobile activity life cycle did not terminated. Still, it is remain active inside the memory of our Android emulator. And then the status became now a pause status. Let us go back to our mobile app activity life cycle and then read the information that appears on that mobile app. So I click this application, in your real smartphone, there is a history activity list that you can switch from one mobile app to the next. Our Android emulator does not have that feature so that we can switch from one mobile app to the next mobile app. So that we can switch to that activity life cycle, that it is still active inside the main memory of our Android emulator, we simply click the icon of that mobile app. So I'm going to click activity life cycle, and we will wait. And as you could see, the information added some data, and then let us try to understand them. A while ago, we read that this constructor main was run by the CPU, and it went to the method handler on start, and then next on resume, and then next on post resume. this 1, 2, 3, 4. When I went to the home screen, what happens to our activity life cycle? Mobile app, it went to the method handler on pause. Therefore, the status of our mobile app that is active remain in the main memory of the Android emulator is a pause status. And then next, it went to that method handler on stop, and then the status now changed from pause and it becomes stop. And then it waits for us to activate again this mobile app. When I activated this mobile app, our activity lifecycle mobile app began now to reawaken. That's why the CPU went to the method on restart and then jumped to the on start once again, just like when we ran first this activity lifecycle mobile app. And then again, it went to that on resume until it reaches the method handler on pause resume, and then our mobile app became visible and reactivated once again. What will happen to the status of the activity of this mobile app if I click exit to terminate? So if I click exit, it will first go to the on pause method handler and it becomes pause. And then after that, after the pause status, the CPU go to the method on destroy. That means that it will erase now the memory fragment of our mobile activity. And that's the time that our mobile app became not visible, vanish, and then it is not anymore active in our Android emulator. Let us go back to the time when our mobile app is visible and active in our Android emulator. And let us trace in our image here what will happen when I click the home screen button to switch to the next mobile app. From resume status, after I click the home button, the CPU went to the method handler on pause, and then our activity status changed to pause. And then after that, the CPU jumped to the method handler on stop, and then the status now of our activity became stop. And then the graphical user interface or layout is not anymore visible in the LCD screen of our Android emulator. By the time that we activate or reawaken our mobile app, the CPU went to the on restart, and then next he jumped to the method or handler on start, and then from the status stop and it is hidden, our mobile app became a status of started, and then it is now the graphical layout is visible now on the screen, and then the CPU jumped to the method handler on resume, and then the status became to resume, and it is ready to accept any events until we terminate our mobile activity. Let us look at the code of this laboratory hands-on activity number 1. Inside the class name main, we can see the default constructor, and this default constructor method is not part of the activity lifecycle, as I explained a while ago. If we scroll down below, we can now see the the method handler on create. And this is the first method handler that when we run for the first time our mobile app, the CPU jump to this method handler and then execute whatever the code that we place inside this method. And then after that, the CPU went to on start method handler and executed whatever the code that was placed inside this handler. And then next, the CPU went to the method on resume and then ran whatever the code that was placed in this method handler on resume until it went to the method handler on post resume and then ran these following codes. When we switch to the next, when I click the home screen button, the CPU jumped to the method handler on pause and ran whatever the code that was placed in this method handler on pause. And by the time that we reactivate our mobile app, the CPU jumped to the method on start and then ran once again whatever the code that was placed here, and then it jumped to that on restart until it reaches the method handler on pause resume. This is what event-driven programming. Write your questions and comments down below or post it in our Google Classroom. That ends our topic for today. I hope you have learned in my class. Thank you for watching. God bless us.